morning. Reverend So, I'm Ajit Kumar of 8th semester and I'm delivering my seminar presentation on neural architecture search. So first of all, we have to understand that what is NAS? Automatic Neural Architecture Search is what media advertise as AI that creates AI. Neural architecture search is the process of automating architecture engineering, that is finding the design of a machine learning model, where we need to provide NAS, a dataset, and a task, where the task can be anything. It can be regression, classification, and it will give the architecture. And this produced architecture will work best among all architecture for that given task. NAS can be seen as a subfield of AutoML and has a significant overlap with hyperparameter optimization. Now the question arises is, why is NAS important? Designing a model manually is time consuming and needs a group of intellectuals to design one. However, there can be infinitely many ways one can design a model, and it is quite tedious task to design all the models and then checking it manually that which one will have the best performance. Suppose that we are designing a neural network for real estate business. So the neural network can have many number of hidden layers. So how can we decide that how many number of hidden layers will be perfect for that real estate data set? Like we don't know that there could be 4 hidden layers to there can be 5 hidden layers, there can be 6 hidden layers. Like suppose that the first hidden layer contains 8 neurons, the second hidden layer contains 10 neurons. Like it can contain any number of neurons and any number of hidden layers. So how can we find that which neural network will have the best performance? So we can only know that which neural network will have the best performance by designing all the possible neural networks and checking their outcome and result manually, and then checking that which one produced the best output, and on the basis of that analysis we can say that this architecture is doing best for this data set. Now discussing about the framework of NAS. Almost all NAS algorithms are based on the trial and update framework, where we start with a set of initial architectures and assuming that better architectures can be obtained by slight modification, applying different operations on the existing architectures, and if the present architecture will produce better output than the previous one, then we will preserve this architecture and we will iterate this process again and again and again until we'll get the best architecture for that given data set and for our given task. Well, there are 3 fundamental requirements in NAS. Well, the first one is search space. Well, we have already discussed that there can be infinitely many ways one can design a neural architecture. So all these neural architectures which can be possible for that task, for that data set, these comes into the search space. Now the second one is the representation, where we define the transition between individuals, the transition between different architectures. Now the third one is evaluation method. Now we will look at the methods which can be used in NAS. Well, basically there are two methods which can be used in NAS. The first one is reinforcement learning and the second one is genetic CNN. Reinforcement learning is also known as reward and penalty method. Well, we can understand this with an example. Suppose that when we bring a puppy into our home, at the very meantime, he doesn't know how to behave, how to breathe, how to sit, where to poop, and how to live in the house. So what we simply do is we ask him to perform the task, like sit here, sit there, and if he performs that task perfectly, then we will give him a treat, and if it doesn't perform that task correctly, then we will simply scold him that no, this is not the right way to do that thing. In the same way, we use this reinforcement learning for finding the best architecture in NAS. Heavy uses an RNN controller which proposes network architecture. The proposed models are then trained, and if the trained models performs well, the controller gets rewarded. And if it doesn't, the controller gets penalized. By using this mechanism of reinforcement, the controller gets updated again and again and again. As the process repeats, the controller learns to minimize the expected validation error and start proposing better and better architecture in the next iterations. But this entire process is computationally very expensive. When this process is used on the Cipher 10 dataset for finding the best architecture by using NAS method, it used 800 GPUs for 28 days repeatedly, and the produced architecture has an error rate of 3.65, which was 0.09% better than the manual designed one, and it was 1.05x faster than the previous one, which was manually designed. And the second method which is used in NAS is genetic CNN, which is genetic convolutional neural network. As we know that NAS is still under research or is a research topic, there are not as much advancement made in this area, and that is why genetic CNN is still under research. And what we know till now is that heavy use genetic algorithms with CNN, and we know that the genetic CNN has relatively low accuracy as compared to reinforcement learning method. Now, coming on the conclusions, as you know that designing all the neural network architectures manually is quite tedious task and is time consuming, because we know that there can be infinitely many ways a neural network can be designed. So if we can design the best neural network, or the neural network which will produce the best output just by using the machine, then it will be quite beneficial for the human being and for our upcoming future and for the machine learning technology. That is why NAS seems quite promising for future. And as we know that a single medicine will not work best for all disease, in the same way a single neural network architecture will not work well for all the kind of data set or for different kind of data sets. That is why we need different neural network architecture for different data sets, and designing all these neural network architectures for all these kind of data set is really time consuming. And if machine will do that work for us, then this will simply save our time, our effort, our capital. So that is why NAS seems the future of machine learning and the future of computer science. And that's all. Thank you.